All right, welcome back. So we are on page 11 of Unit 9. And on page 11, I threw a sine graph on there and a cosine graph. So no transformations, no moves, no making it wider, short, smaller, anything like that. Just to talk about a little bit of the derivatives and how they figure them out. Now remember, a derivative is the slope of a function at a point. So when I'm talking about the sine function, if you look at these peaks and stuff, if I draw a tangent line and I figure out the slope, if the slope of any horizontal line is going to be 0. So at pi over 2, if the tangent line, so the slope of the tangent line at that point is 0. Same thing happens down, same thing happens down here if I draw the tangent line, the slope is 0. Same thing happens here, slope is 0. And same thing happens here. So when I think about that and I take it over to my other graph, at -3 over 2, I have a 0 there. Negative pi over 2, I have another 0. Excuse me. At pi over 2, I have another 0, and at 3 pi over 2, I have another 0. Now, it's hard to see there exactly, but when we start talking about some of these other points, so if I were to draw a tangent line on this graph here on right there, okay, this is going to have a slope that's going down, so it's going to be a negative, and specifically the slope is actually going to be a -1. And if I go the reverse way, at this 0, if I draw a tangent line, that slope is going to have going the reverse way, +1. So these kinds of things happen. So I attached an applet to the Google Classroom. So do you look at it? You can move the sine and cosine around. You can look at it and they show you different parts of the sine and cosine curve. And they show you why, like what the slope would be at this point and what the slope would be at this point. So when we're at 0 here, the slope is actually 1. When we're at pi, I just showed you the slope is -1. So you can start seeing this curve here. And doing that, and it would continue going the other way, going down like this. And so when you compare the two curves, if I give you sine, the derivative of sine is actually a cosine curve. Okay, so the derivative of sine is actually cosine. And if I kind of do the same thing in here, now you can again look at that applet and change it around. They have some different things on there about, switch it to which function you want it to be. But if I draw tangent lines at all these points, down here negative pi, it's 0. The slope, any horizontal line is 0. At 0 there. So any peak or any valley, low point, it's a 0. And if I draw a tangent here, very similar to what I did on sine, draw a tangent here, whoa, should be touching. Slope of there is -1. And actually when you do it on going up the way here, the slope of this one is a +1. Okay, so pi over 2 is a -1. And 3 pi over 2 is a +1. Okay, so this curve actually does this. It goes up here and actually comes back down here. So when you look at this and compare it to, yes, they are related to each other. Derivative of sine is a cosine curve. When I look at cosine, it would be nice if they just switched back and forth, but compare these two. The sine curve initially started at 0 and went up, but now it started at 0 and went down. So the derivative of cosine is a negative sine. Okay, so those are like a couple things, some basic ones to know. They're also we're going to refer to e to the x. The derivative of e to the x actually is itself. It gets more complicated when you have other things involved, but the nice thing about e to the x is it's always itself if we're just talking about that function. So those are going to be a couple things you're going to need to know. And take a look at that applet, slide the little slider around and take a glance at look in the slopes of that. Thanks, bye.